Hello, this is deriving a unit circle. Okay, so to begin with, what is a unit circle? So a unit circle is a circle that has a radius equal to 1. So that means that all of these, all the way throughout the whole circle, is equal to 1. Now, if we take a closer look at the unit circle, we can see the origins of the unit circle. So if we look at the first quadrant, we see that 3 angles make up the first quadrant, and these 3 angles come from triangles. So we have one here, another one here, and another one here. So we have a 30-degree one, a 45-degree one, and a 60-degree one. And these 30, 45, and 60-degree triangles are from our special right triangles. Okay, so we look at our first triangle from the unit circle is the 30-degree one. So it's a 30, 60 degree, 90 triangle, which is one of our special right triangles. So since we had said in the beginning that the radius of a circle is always 1, and then we see that in this case this is a hypotenuse, so it's right here. So then we know that we'll label this side R since that's the radius, and then this side is equal to 1. Now we're going to go ahead and label this one X and this one Y. So if we remember the rules from the 30, 60, 90 triangle, we have the side opposite of 30 degrees will be Y, the one from 60 degrees will be X, and the one from 90 degrees will be R. And then according to the rules, we have the side opposite of 30 degrees is a certain length, and then this side is the length of this side times the square root of 3, and then the hypotenuse is twice the length of this one. So now we know that we have one length of one side, which is the hypotenuse, and it's 1. We can figure out this one since we have said that it's 2y, and it's twice of this one. So we solve for y, and we divide by 2, we get y equals 1/2. Okay, so then we get y equals 1/2, so that means that that's the length of this side. So this length is 1/2, and then since we have figured out y, all we need to do is plug it into this. So it's 1/2 times the square root of 3 equals x, which is the square root of 3 over 2 equals x. So then we have found this side. Now if we draw this triangle on a quartered plane and have the 30-degree be on the origin, so this is, we see that we have 3 points, the origin, this point, and then this point. So we label our points. This one is 0, 0, and then since the length from here to this point is the square root of 3 over 2, that would be our x. So it's the square root of 3 over 2, and then since it doesn't move up any units, so it's 0. And then this one is the square root of 3 over 2, and it goes up 1/2. So if we see this point of the 30 degree, and we look at our unit circle, we see that we have that point in our unit circle. So now, if we look at the next triangle. The next triangle we have is the 45-degree one. So we'll work with the 45, 45, 90-degree one. Now according to the rules of the special right triangle, this side is equal or congruent to this side. And then this would be a hypotenuse, and the length for our hypotenuse will always equal 1 because that's the radius side of the triangle. So now for our 45, 45-degree triangle, we will label this one X and this one Y, just like we did in the other triangle. So then we know that these two are the same length. But what about this side? So the 90-degree is any length of this one times the square root of 2. And since we know that our hypotenuse is 1 already, so now what we have to do is solve. So we divide by radical 2, we would get y equals 1 over radical 2. But since we can't have radicals at the bottom, we will multiply by radical 2. So you multiply by radical 2, and you get radical 2 over 2. So that's the length of y. So that's radical 2 over 2. But y is equal to x, so x is also radical 2 over 2. So we label them under triangles. And then the same thing that we did like the other triangle, if we draw it on a coordinate plane, with the angle being at the origin, and we label our points. So this one would be 0, 0. Then since the length from here to here is radical 2 over 2, so it's radical 2 over 2, 0. And then this one would be radical 2 over 2, comma, radical 2 over 2. And we get this point. So if we look over here, we have that point on our unit circle. So that's how we get the point and the degree here. So now for our last triangle, we have one that is 60 degrees on this side. So this one is the same as a 30, 60, 90, only that it's flipped like in a certain way. So now, so it is the same thing as this triangle, only the y will not be facing the 30 degree and the x will not be facing the 60 degree. So in this case, the y will be facing the 60 degree and the 30 degree will be x. And then we had said that our hypotenuse will always equal 1. Okay, so it applies to the same rules as this one. Only this time, since our x and y are facing different degrees, then we're going to solve using this chart. So we know that our radius is 1, and the length of x, if you multiply by 2, we get 1. Since 1 is our radius. Okay, so you divide by 2 on both sides and you get x equals 1/2. So then that's the side going across from the 30 degrees. So then this is 1/2. Now we just do 1/2 times the square root of 3 over 1 to get our y. And with the square root of 3 over 2 equals y. So that's the length of our y side. So now we're going to do what we did in the previous two circles and draw it on a coordinate plane. And we have our 3 points. Okay, and then, so this would be 0, 0, since it's at the origin. This one would be 1/2, 0, and then this point would be 1/2 radical 3 over 2. And if we look at this point, it is our third point on the unit circle. And then that's how it goes all the way around. Is that the values change, so in this one it's a negative positive, both are negative, and then it's a positive negative. And then also, if we look at this side, our hypotenuse on the triangles is our terminal side, and then the side that's on the x-axis for all the triangles is our initial side. And then we have our angle here, and just like here we have our initial and our terminal, initial, terminal, initial, terminal. And that is how we derive our unit circle.